All right, so this is lesson 20.3.2, the standard form of a quadratic function. We've been looking at the vertex form, and for the next couple of days of classes, we're going to be studying the standard form. There's two main things we're going to be looking at today. The first is we're going to be able to analyze quadratic functions not by looking at the vertex form, but by looking at the standard form. What you're going to discover is that the vertex form, which is what we talked about before, what we were just finished on, the vertex form is information rich. It tells you where the vertex is, it tells you what the maximum or minimum is, it tells you all kinds of information. The standard form does not tell you as much information. Okay? So we're going to have to grapple with that. And then we're going to be looking at applying quadratic functions to situations. And there's a type of question in high school math called maximum or minimum problems. And sometimes when you're taught this, you're taught it as like a single lesson. Let's learn about maximum and minimum problems. I prefer to do like one now and a couple later. And then when we do get to the lesson, you've seen them already. Okay? So to begin with, we're asked in a warm-up to simplify this quadratic function. Of course, what this simplify word means in this context is to multiply this out. And x minus 5 quantity squared means x minus 5 times x minus 5. And there will come a time, probably in Math 30, where I will expect that you don't have to write out x minus 5, x minus 5. You know that's what it is. So when you FOIL it out, you get x squared. I'm going to leave this 3 alone just for the time being. You get x squared minus 5x minus 5x plus 25. And then, of course, we close the brackets and add 7. So there will come a time where you shouldn't need to, and many of you don't need to now, you shouldn't necessarily need to write x minus 5 to know what that means. For goodness sake, don't ever do something crazy like that. That's just not true. X minus 5 squared means x minus 5 times x minus 5. This is wrong. Don't do that. Okay, well, we can simplify the negative 5x plus the negative 5x and get negative 3 times x squared minus 10x plus 25. And there will come a time where I think it's reasonable to say that you should be able to go from x minus 5 quantity squared to x squared minus 10x plus 25. You shouldn't necessarily have to write minus 5x minus 5x. Okay, if you have to, you have to. If you find yourself cutting corners, which means taking shortcuts, and you're getting the wrong answer, then perhaps you shouldn't make those shortcuts. Okay. Of course, now we have to multiply that by negative 3. So negative 3x squared plus 30x minus 75 plus 7. By the way, just again, you know me, there's content and then there's math in general. When you look up top here at these three things, negative 3, x minus 5, x minus 5. When you have three things multiplied together, you multiply two of them and then multiply by the third. You do not multiply that negative 3 into the first x minus 5 and multiply it into the second x minus 5. If you wanted to include the negative 3 in the first round of multiplication, then what you would end up getting, I'm just going to write this in a different color here, is you wouldn't get this, you would get negative 3x plus 15, and then you would have to multiply that by x minus 5. I think what I've written in brown above it is easier. X minus 5 times x minus 5 is easier on the brain than what you're going to have to deal with here now. All right, we're almost done. We do have the 25 and the 7. Pardon me. We do have the 75 and the 7 that we can add together. So we get, for a simplified version of this, negative 3x squared plus 30x. And that is, I misspoke, it's negative 75 plus the 7. I believe it's negative 68, correct? Okay. So I want to demonstrate something to you. We started off with negative 3 times x minus 5 quantity squared plus 7. Is that right? Is that what we started off with? Okay. All we have done is written it in a different form. And just to demonstrate that to you, I'm going to enter in negative 3 bracket x minus 5 n bracket squared plus 7, and I'm going to adjust the window settings. Don't worry about why I'm doing this. I want you to see a pretty decent picture of the graph. I think that might do it. That might be okay. Nope, I was off on the wrong side. We'll go up a little higher too. Let's go 10. What did I do there? Didn't I put a negative in for x? Oh, I didn't. There we go. Okay. You can see the graph, right? Okay. And that's what I get when I enter in negative 3 times x minus 5 quantity squared plus 7. What if I put negative 3x squared plus 30x minus 68? Now, of course, if I graph this and it's identical, you can't tell that it's graphing it, right? Well, I can remedy that by in y. I don't know if you know this or if I've shown it to you. If you scroll over to the left of y2 and repeatedly hit the enter key, you can change what that graph looks like. And on my calculator, I want what I call the little bouncy ball, which is this thing. So here comes the first graph. Now here comes the second. And you can see that it's riding along on top of the first. So they're the same thing. They mean the same thing. They're just written in different forms. And it turns out that that form that we found is in standard form. This is worded a little funny. I need to change the wording a bit here to make sure you understand for next time that I teach this. But this is not standard form. When we simplified it, we got standard form. That's what this is saying. Okay? So this is vertex form. That's what we've been studying for 2 days of classes. And now I'm going to have to go by memory, but I think I have it. Y equals negative 3x squared plus 30x minus 68 is the standard form. Okay? So the standard form is written this way. ax squared plus bx plus c equals y. I want you to notice that in vertex form, x and y are the variables. The parameters are a, p, and q. In standard form, x and y are the variables. The parameters are a, b, and c. Why do we use a in both? Because the a in vertex form will always be the a in standard form. In other words, if you looked only at this result that we got down here, if you looked only at this, the only thing you can reliably tell me is this is a parabola that opens downward and is narrower than x squared. There's one other thing that you will learn in a bit that you can tell. But you can't tell me where the vertex of this is by looking at this. Okay? So that's standard form. So even though the standard form of a quadratic function contains very little information that's visible to you, it's still used a lot. Today what we're going to be doing is using the standard form to find properties of functions, but what this is really about to begin with is learning how to use your graphing calculator to answer questions. Okay? So for each quadratic function, identify the direction of opening, the maximum or minimum value, the x and y intercepts, the coordinates of the vertex, the equation of the axis of symmetry, and the domain and range. Okay. Well, this is too bad it's not in vertex form. If it were in vertex form, we could answer all those questions, right? But we do know something about this. We do know that A is equal to 2. So we know the direction of opening. It opens up. All right? We know that all quadratic functions have a domain of x as any real number and a range of y is either greater than or equal to something or less than or equal to something, right? I'm going to write both of these down, and don't write both of them down. I'm going to tell you it's going to be one of these two situations. We don't know the number yet. I want you to think of which one it's going to be. And again, I'm not looking for people to shout out answers. I'm asking you to think. Is this parabola going to have a range where y is greater than or equal to a number, or is it going to be where y is less than or equal to a number? Well, you have to visualize the fact that it opens up. And if it opens up, there's a minimum. There's a lowest point. I mean, I think we can all visualize this shape, but the point is y will be greater than or equal to some value. So we're definitely going to be dealing with this situation. We just don't know this number yet. The vertex is going to have coordinates of two numbers. The y coordinate of the vertex is going to be the number that y is greater than or equal to, right? You understand that I'm talking about q? Okay. The x coordinate of the vertex is going to be some different number. If we can find these numbers, we kind of have most of the answers to the question. Since it opens up, there will be a minimum of y equals that number. See, everything is all rolled into one idea here. If you know where the vertex is and you know which way this thing opens, you can answer anything about the question, except for the x and y intercepts. That's a little bit different. I'm going to save that. So how do we find out where the vertex is? Well, you graph it on your calculator. So I want you to follow along very carefully here, because confusion can result here. People can get confused and frustrated when they graph things. So I'm going to graph 2x squared minus 8x plus 13. And I'm going to start by going zoom standard all of the time. That's not always going to work, but it will for the time being. Double check your entries, go zoom standard, which is zoom 6. And then what you want to do is adjust your window settings so you can see more information. Okay? And I think I mentioned this yesterday. I'm pretty sure my classes are blending together right now, but I'm pretty sure I used this kind of idea yesterday, which is that this is a bunch of wasted space. Would you agree? Did I talk about this yesterday? And this is a bunch of wasted space. By the way, I can see there's no x-intercepts, right? So when I go zoom standard, it goes from negative 10 to 10 for x, and it goes from negative 10 to 10 for y. Well, if I want to, only focus my attention on this part, then maybe I should go, I'm going to go negative 5 to 5. There's a bit of wasted space here too. I also want to see more information up top here, so I'm going to broaden my horizons vertically. I'm going to go from, let's say we'll go negative 3 to 5. The red ones are what I want to zoom in on. And I'm going to go from, let's go 3 up to, I don't know, up to 20. That's not to scale. Let's see what happens here. I believe I said negative 3 to 5, correct? And I said 3 to 20. Of course, you don't have to use these exact numbers. But what we want to be able to see is a pretty decent picture. That's filling most of my screen. I can see the y-intercept. So how is it I find the coordinates of the vertex? Well, would you agree this is the key to the whole problem? You go to your Calculate menu, which is second trace, and you choose minimum, because that vertex is a minimum point on the graph. And when you do that, it's going to ask you a question, left bound. And all that means is make sure your cursor is to the left of the minimum value that you're trying to investigate. And mine happens to be, but you can scroll around using left, right. It doesn't have to be really close. It will work if you put it here, but I would say you should put it reasonably close. Once you've put that in the left position, hit enter and it will say right boundary. And now you're going to scroll over to the right of the vertex. And again, it doesn't matter as long as you've passed it. And you're going to hit enter again. And what the calculator is about to do is look between those two. It's going to start calculating y's and calculating y's in between until it finds some lowest value of y. And then it's going to spit out the result. It does ask you to guess, and I don't quite know why, but just hit enter, just ignore that. And it grinds away for a bit, and it tells us this. Now, some of your calculators are different. Mine happens to say 2.0000005. Does anybody else's say that? Does anybody else's say a different number at the end? Okay. Those numbers may not even match. I find it depends on where you put the cursor. Does anybody say exactly 2? It doesn't even have decimals after it. Okay. It depends on where you put the stuff. Put the cursor. But you need to interpret this as meaning that this is just the calculator doing some rounding stuff. It's not doing math in an algebraic sense. It's doing it in a numeric sense. It's doing some calculations and it's saying, well, that's close enough. So it's at 2,5. And once you know it's at 2,5, a lot of the rest of the question is easy. We are missing, by the way, the axis of symmetry. Which is at x equals 2. You get the point that if we find the coordinates of the vertex on the calculator, you know P and Q. Okay. There's x and y intercepts to find as well. Now, we're going to find the y-intercept first on our calculator. Yes? Thank you. I wrote down the wrong number in here. This is a 5. Is that what you're going to tell me as well? Okay. So we're going to find the y-intercept first. Now keep in mind, I'm going to tell you right now, you don't need a graphing calculator to find the y-intercept. But I'm going to show you how to find the y-intercept. The y-intercept is where x equals 0. Your calculator, when you have any graph on the screen, your calculator allows you to enter any x coordinate and it will calculate the y coordinate. So all we do here is we go trace and we're going to enter 0 for x. That's it. When I do that and I enter 0 and then enter, it tells me y is 13. Well, that means the y-intercept is 13. Do you suppose that that's a coincidence? No. Because if x is 0, then 2x squared would be 0, and negative 8x would be 0. The constant term, the value of c, what we're going to call c, will always be your y-intercept. Is it clear looking at your graph that there are no x-intercepts? Its vertex is above the x-axis and it opens up, so we're done. Let's try another one. And I'm going to go a little quicker through this one. We don't need to have as broad a discussion. Let's graph this first. Y is equal to negative 3x squared plus 6x plus 5. And again, I've mentioned this, I think, before. Sometimes I just enter x squared by hitting the x key twice. Double check to make sure it's entered correctly, and then we're going to go zoom standard. And if we need to correct things after we go zoom standard, we will. I think that's pretty good. Although, would you agree there's some wasted space to the left and the right? I wouldn't mess with the vertical window settings. I think it's pretty good vertically. It's taking up most of the screen vertically. But I might go instead from negative 10 to 10, I might go negative 2 to 4. Doesn't have to be perfectly centered. But if I go from negative 2 to 4 for x, what happens? I get a nicer parabola. And believe me, for finding x-intercepts, which I haven't shown you yet, you don't want the parabola to be too steep. It becomes complicated. Well, let's find the vertex. Oh, by the way, before we do, what is the value of a? Negative 3, right? So you know a is negative 3. If we only knew p and q, we would be able to say where the vertex is, what the domain is, what the range is, what all of that stuff is. Well, domain is any real number, regardless of p and q. So I'm going to go to my calculate menu, but I'm going to choose maximum because this parabola opens down. And if it opens down, then there's a maximum value. I think you kind of figure out what we're going to have to do here. Left, right, enter. Put your cursor to the left, hit enter. Put your cursor to the right, hit enter a third time. It's at 1,8. Now, some of your calculators may say 1.000 something. Does anybody say exactly 1,8? It's a luck of the draw. You just happen to put your cursor in a place or places where the calculator spit out that answer. But x is 1 and y is 8. So that means p is 1 and y is 8. I feel as though other than the x-intercepts, I shouldn't have to really explain this, but I will. This parabola opens down. By the way, it would be narrower than x squared because a has that 3 in it. The vertex is at 1,8. The domain would be any real number. The range would be y is less than or equal to 8 because it opens down. The axis of symmetry, please on an exam, on a written response, do not write that assuming that it's okay to write that. We're in learning and teaching mode. I'm abbreviating. The axis of symmetry would be x equals 1. What else do we want? Domain, range, vertex, it opens down. Y-intercept, without looking at your graph, you should know the y-intercept is 5. It's the constant term. If you wanted to, you could go trace 0. By the way, you could also use your table for that. You could go table set, put independent on ask, go to your table, and enter 0 for x and see that y is 5. By the way, despite the appearance in table set of everything, You cannot set it up to enter y and have it calculate x. It doesn't do it. Okay? I think we have everything except for the x-intercepts, do we not? Okay. So how do we find the x-intercepts? Well, go to your calculate menu. I want to say we did this yesterday. Didn't we? We choose 0. We did this yesterday. I don't remember where or when or... Oh, we did it to check our work for some of the answers we got algebraically. You choose 0, and then you put your cursor to the left of the x-intercept you're interested in, hit enter, put your cursor to the right, hit enter, and then hit enter a third time. One of your x-intercepts is approximately 0.63, and it's a negative. We're going to learn more about x-intercepts in the coming weeks, literally weeks, but in the next few days specifically, but it's going to continue into the next unit. And then we can repeat that and move our cursor closer. So you see there I just entered 2 rather than scrolling. Go left and right of that other x-intercept, and it's about 2.63. So those are the 2 x-intercepts. Any questions with that first set of examples? It's really just about using your calculator. All right? Another question we're going to do on our calculator. A diver jumps from a 3-meter springboard with an initial speed of 6.8 meters per second upward. Her height in terms of time, height as a function of time, is equal to this equation. And we're asked a number of things. So what does this equation mean? It means if you put 1 in for t, you will find her height after 1 second. Okay? If you put in 0.3 for t, you'll find her height after 0.3 seconds. We're going to graph this on the calculator. We're not going to worry about sketching it by using a vertex approach because we don't know the vertex form. So we're simply going to go y equals negative 4.9 x squared plus 6.8x plus 3, but we're not going to go zoom standard. The reason is this is not just a math equation, this is an application. So first of all, we have to use some common sense here. That if the springboard is 3 meters above the water, then her height at t equals 0, this is time, her height at t equals 0 would have to be 3 meters. That's where she starts. She jumps. We have to use some real world knowledge. She jumps, so she's going to go up. She's not going to continue going up. She's going to reach some maximum and go down. So we kind of, I think we suspect that we know the graph will look like that. Do we not? Isn't that common sense? How do we look at that on the graphing calculator? Well, for my window settings, I'm not going zoom standard. I'm going to go from 0 to something more than 3. Would you agree it would be very bizarre if she jumped off of that and rose to a height of 10 meters above the water before she started falling? Okay. I think if we go 0 to 10, that's more than enough. I'm going to go 0 to 6. And if we need to go further, we can. Would you agree, and whether you've seen somebody jump off of a springboard or not, you know what we're talking about here, that she's not going to be in the air more than a couple of seconds? I might go to 3 seconds. And if we need to go further, we can. Now, I'm going to tell you right now that if I want to go up to, say, 6, well, let's do the time first. Window, let's go from 0 to 3. For y, I'm going to tell you whenever you set up your y window settings for an application, don't start at 0, start below 0. You're going to see y in a few minutes, or in a minute. I'm going to go from negative 2 to 6 meters. Not from 0 to 6, from negative 2 to 6. And when I go graph, well, I did pretty good. She's not even in the air for 2 seconds. Now, first of all, You understand that this part of the graph is meaningless because she's hit the water. Okay? We're not going to look at that part of the graph in terms of describing what's happening, but we need to see that part of the graph to calculate something. Okay? So this is what the graph looks like. And this is somewhere between, would you agree it's somewhere between 1 and 2 seconds? I better be careful here. When you go window, I've never told you this, I don't think. You know what the scale is? It's where you put a tick. So if I put the x scale at 1, when I look at the graph, each of these ticks is 1. If I were to go back and change that to x scale 0.5 and graph, it's just going to show a tick every 0.5. So that's why I was able to see when I had x scale of 1, and I like x scale of 1 unless it's a lot of ones all crowded together. When I look at this, I can see, oh, it hits the water, she hits the water somewhere between 1 and 2 seconds. Let's answer all of the questions. What does the y-intercept represent? Well, it's where she starts. Her initial height. Of 3 meters. What's the maximum height that the diver reaches? I guess we'd better find the coordinates of that vertex. So we go calc, intersect, not intersect, calc, maximum, put my cursor to the left of it. Now rather than scrolling, you could just go, well, I think 0.2 is to the left of it. And 1.5 is to the right of it. Again, it doesn't have to be really close. Don't go crazy and go like 1,000 seconds. Be close. And then enter. So what is the maximum height? 5.36 meters. When does she reach the maximum height? 0.7 seconds after she leaves the board. This goes back to what we talked about yesterday and the day before, that when you say a maximum value is, it's the y-coordinate. And the maximum value happens at the x-coordinate. She has a maximum height, I'll go to 3 decimals for each, 5.36. H max is 5.36 meters at 0.694 seconds. Yeah. How long does it take the diver to hit the water? Well, what we're after here is the t-intercept, the x-intercept. And you go to your calculator, calculate function menu. You go to the calculate menu. And you choose 0. And now I hope you're going to see why I've got this tail of the graph that I want to see. Because when I go 0 and I go enter, I have to put my cursor to the left of that, and then I have to put my cursor to the right. And if my screen ended at the x-axis, I wouldn't have anything to put my cursor on. I want a little bit of overhang. 1.74 seconds. What domain and range are appropriate? Well, don't say any real number, because x, which is time, is not any real number. The smallest value of x is 0 seconds. The largest value of x is that 1.74 seconds. The function is only valid between these 2 points. It's not valid for negative values of t, and it's not valid for values of t greater than 1.74. And the range, well, the range would be same thing. The lowest value for y, or the height, is 0, and the highest value is that 5.36 meters. Finally, what is the height of the diver 0.6 seconds after she leaves the board? Go trace 0.6 and read the y-coordinate. That's it. Or go to your table and enter 0.6 if you want to. I'm just going to go trace 0.6, 5.316 meters. Any questions with that example? Okay, now we have one more example to go, and this is number 3. And this is called a max-min problem, or an optimization problem. At a music festival, they have 160 meters of rope, and they want to create a rectangular area for parking, or whatever, to put strollers. I don't know, it doesn't matter. They want to make a rectangular area. Forget about the rest of the question right now. I want you to look at these 4 rectangles. And I want you to think about what I'm going to tell you about them and ask yourself if it's reasonable for me to say this. These 4 rectangles all have the same perimeter. Of course, like an idiot, I'm going to hit that button again. Oh, we're okay. I set this up. I wonder if it's still the same. It is. I set this up so that the width of this is 7. The height of this is 6. So those 2 sides added together are 13. And if you look at the height of this, it's 8. And the width is 5. It's 13 on those 2 sides as well. The perimeters of these are all the same. Would you agree? Would you agree with that statement? Can you buy that? Okay. Would you also agree, however, that even though they have the same perimeters, they have different areas? And I would say that the rectangle probably with the least area would be this one, maybe followed by this one. And these 2, oh, that's tough. You know, you would almost have to put them on top of each other and kind of look at it. I don't know, it's really close, isn't it? But here's the problem. If you were designing this, and it would probably be an engineering problem, not a parking lot problem, what dimensions should you make the rectangle to get the most area? I mean, if they only have 160 meters, they're confined to that. But clearly they don't want to make this. They don't want to make that. They want to make something that has more area. So we're going to learn how to solve this problem. It says, write a quadratic function in standard form to represent the area for the stroller parking. I'm going to call one of these sides x because since time immemorial, we've used x for the unknown. Okay? The only problem is the length of it is a different variable than x. And I suppose what you could do is you could call this some other letter like L for length. Or what you could do is reason out that this has to be 80 minus x. And I'm going to show you algebraically how we get that. What we do is the following. We say that 160 is equal to 2 times the length plus 2 times x. This is L, this is L, this is x, this is x. Those 4 pieces have to add to give 160. Well, if I subtract 2L from both sides, pardon me, if I subtract 2x from both sides and divide everything by 2, I get this for L. If we call the width x, the length is 80 minus x. So I'm dealing with a rectangle with these dimensions. Are you with me so far? What we always want to do, I know you're guided here in this question. It says write a quadratic function in standard form to represent the area. I know you're asked or told what to do, but what we always want to do is come up with an equation for the thing we want to maximize or minimize. You want the area to be as large as possible, so let's come up with a formula for area. Well, it's length times width. Let's multiply it out and write it in standard form. When I multiply this out, I get 80x minus x squared. Just ponder that for a second and see if that makes sense. Okay. That's not quite in standard form. Standard form is this. So, what does this mean? It means, I want to go back to my rectangles here. Let me write this down. Area equals negative x squared plus 80x. Just want to double check. Yep. Okay. That means if this is 160 altogether, can you buy that this is 30 and this is 50? Does that add up to 160 all the way around? Yep. So x is 50. Put 50 in here. I want you to take negative, well, I'll do it on the calculator because I don't want you to make a mistake here. Oh, I'll do it with you. When I say negative x squared, I don't mean you're going to take negative 50 and square it. It means negative 50 squared. That's what it means. And I'm going to add 80 times 50. If you made this rectangular parking area for the strollers, the area would be 1,500 square meters. Would you agree that this looks reasonable? Would you agree if those are the dimensions that it adds up to 160 all the way around? Okay, what would it be then? Well, this would be x, so put x there. And you're going to get negative 5 squared. This is going to square 5 and keep the negative in front, which is what we want, plus 80 times 5. It's only 375 square meters. This one was 1,500. This is only 375 square meters. You get that we could do this all day and just kind of stumble around in the dark trying to find the maximum area? Or what we could say is, and this is the whole point of this question, this is a quadratic function. And this quadratic function opens down, which means there has to be a maximum value. That maximum value is going to tell us the maximum area and the value of x to get the maximum area. It's all about where the vertex of this is. If we know where the vertex is, you know the maximum area and you know how big x needs to be. So how do we find the vertex? We do it in the same way we did the previous questions. You graph negative x squared plus 80x. And now we have to set up the window settings. Do you agree, you're going to have to think carefully on this, and you can look at some rectangles here, that x has to be less than 80? You can't have more than 80 for that width, because then you're not going to have anything. You're going to go over 160 just with the two sides. So x is going to be from 0 to 80. Window, 0 to 80. And now what you're going to do is this. You're going to back out of here, and you're going to go to your table, and you're going to investigate what y is for numbers from 0 to 80. You might even decide to set up your table to start at 0 and go up by 10 automatically. And then we can go and look at a table of values and see that from 0 to 80, the area rises to about 1600 and then it falls again. That means, my window setting, it would be pretty prudent to go up to more than 1600. Now I'm keeping the y scale as 1, so it's going to have a whole bunch of dots blended together. Right? We don't have to change it, but I'm going to change this to 500 for a scale. Whoops. Change it to 500 for a scale. I can change this to 10 for a scale. You don't have to. Got one too many zeros here. Let's take a look at it. Yep, thinking works. You just have to find the coordinates of the vertex. Calc, max, left, right, enter. X is 40. When X is 40, you get the most area. And the most area you get is 1600. So I know I didn't walk through this in A, B, C, D order. And by the way, let's not worry about D. I don't care about D or C. I want to talk about B. The coordinates of the vertex are at 40, 1600, which means the maximum area is 1600, and it happens when X is 40. By the way, if X is 40, what's the length? 40 as well, isn't it? 80 minus 40 is 40. It's a square. We're going to do one more. What if they've hired somebody who's really smart? They said, you know what? Why waste a whole bunch of rope on a side of the parking area when we can use the side of the hall as one of the boundaries? And what that means now is that, well, let me back up. In this question, all of this added up to 160. Now what's happening is only this adds up to 160. And that means if you call this x and this x, I would like everybody to see if you can figure out what the length would be in terms of x. You have 160 meters of rope in total. Who has it? Yep. 160 minus 2x. Okay, so area is length times width. We multiply that out. And you're I don't want to say you're done. All that remains is for you to recognize that this will be a parabola that opens down, and this is the key to the solution to the problem. Where is the vertex? Because the vertex is going to tell us what value of x will give us the most area, and it's going to tell us what the most area is equal to. I'm just going to hit graph. I don't know if I'm going to have to change my window settings significantly, but I'm going to take a look. I'm going to have to change them significantly. I'm going to have to go up a lot higher. But that kind of makes sense because whoever came up with this idea recognized if you don't waste some of the rope on some of the perimeter, you get a benefit with the area. You get more area. I'm going to double my, I really don't know what it is. I'm going to go up to 3,600. Yep. I find not the intersection. I find the maximum left, right, enter. Oh, this time x is 40 as well. But it's not going to be 40 by 40. If we look at this, if this is 40 and this is 40, that means this is 80. You've got 80 left. 40 times 80 gives you that maximum area of 3,200. But you don't have to think that way. You can just look at the calculator screen and say, the y coordinate there is the thing that is as big as possible, which is area. The x coordinate is what makes it happen. That's it. We're going to see many, many more of these max-min problems. This assignment or set of practice problems is about using your calculator to get numbers. Okay, x-intercepts, y-intercepts, maximum values, where they happen, that kind of thing.